Did you know that you actually haven't touched anything at any time, anywhere? Nothing touches? Nothing? The densest atom is like, a molecule is a, diamond molecule. If you grew one of the atom in that molecule, the other one would be 2 football fields away. If the one you grew was the size of an orange. That's how much space there is in between them, and then the space inside the atom is 99.99999%. So maybe we should pay attention to the largest percentage instead of the smallest percentage. We spend a lot of time paying attention to the 0.0000001% that we call matter, and we spend very little time paying attention and trying to understand the 99.9999999% of the space. So maybe instead of matter defining the space, maybe it's space that defines matter. And I start to realize that. You all following me? This is a fundamental change in consciousness to actually go in the world and first of all realize that you're mostly space, and that maybe the space is defining you instead of you defining it. So it was many years of studies in physics. Many years of studies in physics, some 15 years, and I did most of my studies independently because I didn't want to have to answer to anybody about the way I thought and what I wanted to think. And I had to finance it independently, so I actually lived in a van for almost 5 years at one point, so I didn't have to pay rent, and I could just study and study and study. Most of the people that write physics at that level, meaning most people that write physics in unification theory, are usually in their 70s, 80s, because it takes a long time to learn enough physics to get to that level. But because I was inhibited by, having courses that didn't, go in the direction I wanted to go, or having to do exams and all this stuff, I was able to move very rapidly. Eventually, I got my first sponsor that took me out, literally, of my van. The deal with him was that I had to agree to go to physics conference. And, I wasn't so keen on that because I already had a bunch of run-ins with the physicists, and, I wasn't so excited to put myself in front, with like a big bullseye on my head. And so... But he dragged me there, and so this was a private conference, and I went there with this book called Gravitation. Gravitation is like the Bible of relativistic equation, Einstein field equations, and it's written by giants of physics, Wheeler, Thorne, and Mesner. It's thought to be the Bible of relativistic physics, and it's called Gravitation because you can see it's quite thick, so when you pick it up, you know everything you need to know about gravity. And I was at this conference and I kept on asking annoying question. Why annoying? Because in advanced physics conference, usually you don't ask question that has to do with fundamental physics. Everybody there is supposed to have accepted fundamental physics, learned them a long time ago. They don't want to revisit it. You're supposed to be in like, 11-fold geometry of Calabi-Yau space, string theory, all this stuff is happening, really complex equation, and I kept on asking basic questions. For example, I was getting there. Gee. At one point, I pulled out my gravitation and I opened it on page 719, and I said, so if I understand well, from all the equations that we've been studying, the universe model that we have today resembles a balloon, and this is actually the example they give you in physics text. And it's a balloon that's expanding that has pennies glued to it. And the pennies are representing galaxies. And as the balloon expands, the galaxies move away from each other. And everybody's like, yes, Nassim, that's correct. And I said, well, the part I'm missing, I'm sure I missed it. I'm sure, you guys can point me out to it and I'll just shut up from there on. But like, what I really want to know, and I haven't found it, I've been studying a lot, and so what I really want to know is where the equation that explains who's this guy. And the whole room, I got a different, response. The whole room became really silent, I always remember there was a student, a PhD student there, and he went like, was drinking his coffee. And I could see the director of the physics department there started to sweat a little bit, and I think he thought I was going to say the word God in the physics department, it's like, oh man, please, not in front of my students. And so I said, hey, let's draw the rest of the guy. And notice that when the balloon expands, yes, the lungs must contract. For every action, there's an equal and opposite reaction. That's, not being accounted for in our current physics. All of our physics today are based on expansion, explosion. It's the male approach to the universe. Our most advanced technologies, our most advanced engineers, and the people that we respect the most in science are people that make these phallic-like symbol large, cylinders. They fill them full of fuel, highly explosive material. It's our approach to space travel. And then, put a little capsule on the end, find volunteers, stick them in there, light the bottom, stand back and go, oh my God, I hope you survive the thing. Send them a few miles up, right? And then at the end it's like large cylinder, then there's a little ejaculation. Poof! Few guys in there. We put fuel in our cars, we explode the fuel, we push a piston down, our car gets going. Everything's on explosion, but how does the explosive side of creation, how the entropic side of creation occur if there is no centropy? If there is no movement to the center, if there is no compression prior? I mean, for a fuel to come to exist, there must be dynamics that compress that energy into that fuel. Right? If the universe exploded from a point, smaller than an atom, which is the standard model of the Big Bang, which I'm not fond of, and I show you why, then something must have put that energy in there. There must be a compressive, there must be a collapsing form of the universe that's occurring at the exact same time as the expansion one. For every action, there's an equal and opposite reaction. And that is some of the fundamental physics. So, now, remember how we said, maybe it's the space, right? Maybe space is the part that's holding all the information. Maybe space, and this is certainly how I was starting to think, maybe space leaks a little bit of energy on the radiative side, and that's what we call the material world. But if that was true, if space is the thing that connects all things from infinitely big to infinitely small, then space would have to be infinitely dense. Wouldn't it? Well, is that true? I mean, doesn't seem like it. So I started to study more. And then I realized, and certainly at the time, now it's becoming more known, more popular, but at the time, something very, very dramatic had been swept under the carpet by physicists. That is that when we start looking at the quantum level, at the space inside the atom, that space is not empty, but is fluctuating at really, really high velocity, at really, really high density, like a lot of energy. It's not empty at all, it's a lot of vibration. When they try to calculate how much vibration is present in the vacuum inside the atom, this is what they found. Present-day quantum field theory gets rid by renormalization process. Renormalization, that's what they tried to do to me at school. Process of an energy density in the vacuum that would formerly be infinite. Let me say that again. An energy density in the vacuum that would formerly be infinite if not removed by renormalization. Right. So that means that the equations themselves showed that the vacuum density at the atomic level in the molecules and the atom are infinitely dense. That's exactly what I had predicted just using fundamental logic. You all following this? Space is not empty, it's infinitely dense. But because it's infinitely dense, then everything cancels out and it looks to you like nothing. Infinite mass. Meanwhile, we're floating in this. That would mean there's infinite amount of energy in the vacuum, and we've got a whole bunch of people on this planet going, dude, there's not enough energy for everybody. What are we gonna do? We're gonna war for it. Right? Well then, when an equation gives an infinity like that, in physics it's not acceptable. It has to be renormalized. That is, you try to find a constant that you can apply to it so you get a finite number. So in this case, and they did that to quantum theory in another way as well, they use this constant. It's called a Planck's distance. You can think of the Planck's distance as the minimal amount, the smallest wavelength that the universe can do, calculated from our physics using, electromagnetic theory and gravitational theory and so on. Paying attention to the 0.0000001% that we call matter, and we spend very little time paying attention and trying to understand the 99.9999999% of the space. So maybe instead of matter defining the space, maybe it's space that the way, if the one you grew was the size of an orange, that's how much space there is in between them, and then the space inside the atom is 99.99999%. So maybe we should pay attention to the largest percentage instead of the smallest percentage. We spend a lot of time finds matter. And I start to realize that. You all following me? This is a fundamental change in consciousness to actually go in the world and first of all realize that you're mostly space and that maybe the space is defining you instead of you defining it. So it was many years of studies in physics. Many years of studies in physics, some 15 years, and I did most of my studies independently because I didn't want to have to answer to anybody about the way I thought and what I wanted to think. And did you know that you actually haven't touched anything at any time, anywhere? Nothing touches? Nothing? The densest atom is like, a molecule is a, diamond molecule. If you grew one of the atom in that molecule, the other one would be 2 football fields